we see this three-layered approach built out. The story has unfolded, depicting a picture that is similar to what we're going to see in our own environments. Now, I will preface this. Your own environments are going to be more complicated than what you're going to see in a Cisco class. Why? Because you have your own personal needs. Your own needs present challenges and perturbations of this that are going to manipulate this. And the great news is it's built for that purpose. So this cookie cutter approach can also be augmented. It's extensible, so to speak. You can change the way that it has been designed to work better for you. But what we can see here, we've got our access layer, our distribution layer, and our core layer. And often we're not connecting directly to the internet, so you would expect routers involved towards the perimeter of our connections to start to do things like run BGP for us, maybe bridge the gaps between our routing domain and the next and do redistribution. But in terms of the internal connectivity, this is a pretty good picture. And we can see here things like low-end layer 2 switches, and they may not be low-end. I mean, we've seen crazy things in the real world, like people using 6500s for access layer switches because they have so many possible ports, which is awesome. And then multi-layer switches at the core, serving as a boundary. They serve as a boundary between the VLANs that exist at the access layer and the direct layer 3 links between all of these devices. When you see connections between multi-layer switches, I want you to think that each of these links is going to be its own unique subnet. More on that later. Now, we are, in this class, going to run a topology that is representative of those layers. We have the access layer switches, ASW1 and ASW2, two of them. And then distribution layer switches, which are multi-layer in nature. And then we're not going to have a core, but R1 and R2 take the place of the core. So we have R1 and R2, and that won't be a challenge to us. And then connectivity to the outside world. So really, this does depict exactly the sort of model that we're going to see. And if I just want to do a show interface status to see the ports that are on this device, you can start to see, yep, we have a large number of ports, fast Ethernet in nature, because these are 2960s that I'm on right here. 2900s, pretty common access layer switches. And then we have gigabit connections that are going to go to DSW1 and DSW2. And I can see those sorts of connections. If I do a show CDP neighbors, I can start to see what I'm connected up to. And then DSW1 and DSW2 are connected up to R1 and R2. And that kind of paints the story for us in our implementation of this topology. So we have this topology as shown here, and it's what we're going to work with. And the more that we understand this topology, the better we'll be able to tweak it, optimize it, and solve challenges when they arise.